So today we're going to talk about Learning Target 2. And Learning Target 2 is divided up into 4 parts. In this video, we're going to talk about the first 3. Learning Target 2 says that we can use exponential functions to model sets of data. So now we're going to be actually writing exponential functions. The first part is to just talk about what the role of a is and then relate it to the y-intercept in the exponential function. So this is what an exponential function always looks like right here. F of x equals a, some number, times b, a different number, to the x power. The fact that x is in the exponent is really what makes it an exponential function. So in this function, f of x equals a times b to the x power, a and b both have very specific roles that alter the pattern of the function. The variable a represents the y-intercept of the function. This is just the starting place. Okay? So that says y-intercept and that says starting place. So in each of the following exponential functions, what is the value of a? Well, if you remember back to the linear function unit, we talked a lot about how the y-intercept happens when x is 0. So here, the y-intercept is right here, which means a equals 1. So this is where I would start. If I'm making a table for this function, I would start when x is 0 and when y is 1, and then I would do the pattern from there. So this would actually be my starting place if I'm making the table. Over here, the y-intercept is right there, which tells us that a equals 3. And over here, the y-intercept is right there, which tells us that a equals 1/2. Now down here on these graphs, a is the y-intercept, so that's happening at 2 because it's counting by 2s, like 2, 4, 6, 8, 10, 12. It's crossing at 2. This one is crossing at 1. I know it's kind of hard to see these graphs, but that's 1 right there. And this one is at a equals, it's right in between 2 and 4, so 3. A is 3. So that's how you find the value of a. It's just the y-intercept. Now moving on to part 2. So now we're going to talk about what the role of b is in the exponential function, a times b to the x power, and we're going to relate this to the pattern of the function. So we have a starting place, that's the y-intercept, that's the a. Now we need to know where to go from there. So the pattern is going to give us what b is. B is just whatever this constant multiplier is over here. So in this function, to find that, I'm going to say 1 divided by 1/2, and that gives me a multiplier of 2. From 2 to 1 gives me a multiplier of 2. And from 4 to 2, 4 divided by 2 gives me a multiplier of 2, which means that b is 2. Over here, 12 divided by 24 is 1/2, so that gives me a multiplier of 1/2. 6 divided by 12 is also 1/2, and 3 divided by 6 is also 1/2. So that means that b is 1/2. Over here, 1.5 divided by a half is actually 3. Okay, there's 3 halves. If you have 1.5 cups of sugar, you're going to have 3 half cups there to make that. 4.5 divided by 1.5 is also 3. And 13.5 divided by 4.5 is 3. So that means that b is 3. So now here, I'm going to take several points. Where am I at there? Okay. And all I really need is 2. So if I'm going to make my table, my first point is 0, 2. And my second point is 1, 10. Okay, that's 0, 2. And that's 1, 10. And that's all I really need to find my multiplier. So 10 divided by 2 is a multiplier of 5, so b equals 5. Over here, I have this point at 0, 1. I have another point at, it's very hard to see this, that's 1, 3. So I have 0, 1, 1, 3. which tells me that my multiplier, 3 divided by 1 is 3, so it's times 3. So b is 3. Over here, I start at 0, 3. That's at 6, so 1, 6. So I have 0, 3, I have 1, 6. And notice how I always write these in order of the x coordinates. That's important because otherwise it'll screw up what the pattern is. So from 0 to 1, and then over here, it's going to be times 2 because 6 divided by 3 is 2. So b equals 2. But it is very important that your x values always count by a positive 1. Otherwise, you're going to get a crazy pattern over here all messed up. So now that we have the a value, the y-intercept, and the b value that comes from the pattern, we can put those together as a and b to write the function, and that's what part 3 is. So if we look over here, how to write an exponential function after you've figured out the values of a and b, we know that an exponential function, they all have the same setup. They're always written like this: a times b to the x power. And I often put the b in parentheses just to help separate it from the a. So if a here is 1 and b is 2, and we know that because this is the same table that is the first table on the previous page. So a was 1 and b is 2. So that means over here, our function is going to look like this: 1 times 2 to the x power. That's going to be our function. If we look at the second table, it's the same ones on the last page. So a is 3 and b is 1/2. So a is 3, b is 1/2. So the function is 3 times 1/2 to the x power. For the last one, a is 1/2, b is 3. Whoops. Yeah. Okay, we're good. So a is 1/2 and b is 3. So that one's going to look like this: 1/2 times 3 to the x power. Now for the graphs, same idea. We found a, that's the y-intercept. This first one has a y-intercept of 2, so a is 2. And we picked 2 points and found the pattern, and the slope, or like not the slope, I guess, the change was a 5 multiplier, so b is 5. So a is 2 and b is 5. So the function would be 2 times 5 to the x power. For the second graph, a is 1, b is 3. So the function would be 1 times 3 to the x power. Or really, you could write that like this. Because whatever this is, you would times it by 1 and you would just get this. Same thing up here with this first one. You might see it like that. Because if you take whatever this is, you're just going to keep timesing it by 1. And that's not going to change anything. So it's just going to be that. For this last one over here, a is 3. And down here, b is 2. So if a is 3 and b is 2, then the function will be 3 times 2 to the x power. And once you have your a and your b value, that's how you write an exponential function, always following that same pattern of f of x equals a times b to the x power. And that's all.